Hi, my name is Eris Borax, and this is my final project for the Electrical Engineering Honors class at Gloucester High School. The idea for my project is to input a number into this LCD using this button and potentiometer, and the binary form of that number gets shown in this array of 8 LEDs. So you can show up to 8 bits of binary or up to 255 in decimal numbers. And I'll warn you now, the LCD is very finicky and delicate, and if I accidentally touch one of these wires, the LCD itself, it'll cause an error, so it could display random digits or whatnot, so I'll just have to reset the program, and that might happen a couple times throughout the video. So without further ado, I'll show you the project working. So right now, this little line here is under the hundreds place, so that's how I know that the potentiometer will be controlling the hundreds digit. And as you can see, as I turn this potentiometer, it changes to 1, and 100 is shown on the LEDs. And then 2 and 200 is shown in binary on the LEDs. And I'll bring this back down to 0 to demonstrate this. I'll press this button, and you see the line jumped, and now I'm controlling the tens place. So I move this potentiometer, jumped up 10, 20, 30, 40, 50, all the way up to 90, and that number is shown in binary using those LEDs. I'll go to 0, and I'll go to ones place, and you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'll go back to the hundreds place. I'll bring it to, let's say, 100. I'll display 137. So you go to 1, and then you go to the tens, change it to 3, and then you go to the ones and change it to 7. So yeah, you can basically choose any number using that system, and here you see 137 in binary. Now, because there's only 8 bits of binary and thus can't display a number bigger than 255, if you input a number bigger than 255 into the LCD, which you can, the array will be false, and it'll wrap around. This is actually a problem that happens in coding fairly often, that a number will wrap around its maximum value. So 256 will read 1, and 257 will read 2, etc. But to prevent that, I have a measure in place. It'll just say too big. So I'll demonstrate. I'll bring it back to 0, 0, 0 and bring it up to a big number. Try to make this 200. And it'll probably jump right to saying too big because the potentiometer is, see, this is what I was talking about earlier, how it'll sometimes glitch out. So I have to reset it, 200. So as I was saying, when I press the button, it'll probably jump to saying too big because the potentiometer is pointed right around where 6 or 7 should be on its range. So it'll be 260 or so and say too big. So see that? Sometimes the button gets sticky. Of course. Yeah, it's big, so I have to bring it back down. 250, right? So right now it's at 250, 240, 250, then 260, it says too big. And I can bring it over to the ones place at 250, right? So it's at 255, right? 111111. I'll bring it down, and I can bring it up, too big. I've used several different components for my project, starting off with the microcontroller that I'm using, the Arduino Mega 2560. I'm also using a button, 2 potentiometers, an LCD or liquid crystal display, 8 LEDs or light emitting diodes, 2 200 ohm resistors, 1 1000 ohm resistor, and 8 100 ohm resistors. And then I'm also using a shift register microchip. And what a shift register microchip does is it spreads out the input of data into several different outputs. So in this case, I'm having one input into the chip output 8 different data bits. which I am using to illuminate the LEDs. And it does this using latch gates and clock data, which is where data is sent out over intervals, sort of like the diagram shown on screen, with periodic highs and lows, and the different pattern of highs and lows tells the shift register how to output the certain data. But it's very complicated. I don't have enough time in this video to explain it. But if you're interested, definitely learn more. It's very a cool piece of technology. Here I have a diagram of my project next to the schematic of the project, both made in Tinkercad. Now the schematics, they're auto-generated, messy, kind of complex, take up 2 pages, and honestly not super useful for explaining the project. So I've included them in case you want to pause and zoom in or have a look at it, but I won't be going too far in depth into it. However, the diagram here is very useful to explain how the circuit works without having to show the actual circuit and things can get messy. So starting off, I'll start off with the shift register microchip and how it works. So as I explained a bit earlier, it uses clock timing to control the outputs. So you'll see that there's 3 lines here that come from inputs, or that come from outputs, sorry, on the board. And one of them is the clock timer, which will send a signal at alternatively high and low voltage, which will be used by the shift register to time and shift over the different outputs and send them in a line to the LEDs. And then the others is the data that will be sent. And I won't go too far in depth into exactly which each cable does. But like I said earlier, you can learn more if you're interested. And you'll notice that there's 2 powers, which go to 3.3 volts here from the board. And one of them powers the chip itself, and one of them is power for the LEDs. And similarly, there are 2 grounds. And then we have our 8 outputs here, which go into these 7 ports and this port. And these go each through an 100 ohm resistor to protect the LED, and then through the LED and into this ground chip here, which goes back into the board. Next up is the potentiometer and the button, also called a push button, also called a momentary contact switch. Now, how the button works is very simple. It takes in current, in this case 5 volts from the board, and it goes through the button and into ground. Now when the button is pressed, it allows the circuit to be completed, but when it's not pressed, there's no contact in the circuit and the circuit's not completed. So this cable connects from that circuit to a digital input. So when this circuit is completed and there's current going through, it will return current, or 1, into the input, and that's how the board knows. And then potentiometer, it's similar to that, except with bigger range of numbers than 0 or 1. It's variable, it's on a spectrum. So it takes in power and goes to the ground, so to make a circuit through the potentiometer. When you turn this, it applies more or less resistance onto the current, and then it returns the value of that resistance in this cable into an analog input. Last but not least is the LCD. Now the LCD consists of lighting in front of which is a liquid crystal film. And the liquid crystal film is manipulated by some circuitry to display shapes and let lighting through. But the way it works isn't super important for my video. What's important is the wiring. It requires 6 digital outputs from the board, along with 2 grounds, and then 2 inputs of 5 volts put through a resistance of 200 ohms, and a potentiometer, which in this case isn't returning the value of its resistance to the board. It is returning the output current with the variable amount of resistance into the LCD, which is used to adjust the brightness of the backlight of the LCD and thus the contrast of the LCD. So to tune how the LCD looks, you can turn the potentiometer, which is very helpful. The next thing I'd like to show you is my code. It's written in Arduino's modified version of C++ on the Arduino IDE. First thing I do here in my code is I include the liquid crystal library, This just includes all the functions from Arduino that I'll need to control the LCD. And then here I am using some of those functions to initialize the LCD, let it know which digital outputs I'm using. And then here I am creating 3 variables to store the pins that the different shift register pins are plugged into. So instead of having to remember which one's 2, 3, 4, I can just write data pin, clock pin, or latch pin when the code needs to use the data pin, clock pin, or latch pin. And then the next thing here is a variable that will be used for the shift register code. And then down here, I'm creating 2 arrays. What an array is it's basically a stored list of information of data points, where each data point is stored separately, usually separated by a comma. And you can use the different items in the list for different purposes. You'll see how I use these arrays later on in the code. And there's different types of arrays, some for storing characters or letters, which the data is stored in strings or non-numerical values. And then there's integer types, which is this one down here, which is numbers. So you can actually do calculations with the numbers stored in the arrays. And then this number here, 9 or 8, is just the number of items that will be in that array. And you'll see how these arrays are used later on. And then here I'm creating a variable called button counter, which will be used in the code that determines what happens when you click the button. And if you'll remember, that's whether you're controlling the hundreds, tens, or ones place on the LCD. And then here I'm creating 3 more variables that will be used for that code, which helps determine the inputs into the LCD number. And this variable right here, called potmax, or short for potentiometer max, is the maximum value of the potentiometer. Now, according to the stats of the potentiometers, this number is supposed to be 1023. However, they're pretty cheap potentiometers, not super consistent, so the value will change. So every time I run my code, or every couple of minutes, it's very helpful to check the value of the potentiometer or what the maximum value is and update this here. So I don't need to go and update every single instance of the potentiometer maximum being used in the code. I can just update it in this one spot and all the instances of it being used will be updated. And I use the maximum value of the potentiometer quite a bit, as you will see. So this is very useful. Then here in the setup loop, this loop will run once when the code begins, initializing the serial monitor, which I'll use to print this potentiometer maximum value, which I use frequently. I'm initializing the LCD at 16.2, which is the number of rows and the number of columns. And then I like to clear the LCD every time when I start the code afresh, just to clear anything that might have been on it from the last code. It'll stop any misprints. And then I'm declaring those 3 pins that I'm using for the shift register as outputs. Then the next thing I'm doing here is creating a function called shift_right that will make it easy to deal with the shift register. So what the shift_right function will do is I can declare a desired pin, which is whichever shift register output I want to control, and then a desired state, which is 0 or 1, so whether I want the output pin to be 0 or 1. And this function, or how to make this function, was given to us in the tutorial that was given to us for the shift register. So I didn't do too much research into the workings behind it. It's fairly complicated, so I won't go too in-depth into it. Then next here, I'm creating another function, and this one, called convert to binary, will take an integer input, in this case, in the number that I input into the LCD screen, and convert it into an array that I can then use with the shift register to illuminate the LEDs. So the first thing I do in this function is I convert this integer input into a string form. So I'm calling it decimal, and decimal is just a string version of the input. And then the next thing I need to do is I need to calculate the number of zeros I need to attach in front of this string. So because I have 8 LEDs, I can represent up to 8 bits of binary, and thus 8 ones and zeros. But if I wanted to display a number which is binary form is less than 8 bits long, I need to add zeros in front of it. So to figure out the number of zeros I need to do in front of it, I subtract the length of the binary form from the number 8. So this decimal length is the length of this decimal variable here, it's the number of characters in it, and subtracting it from 8 will return the number of zeros I need. And then this for loop here, and this string zeros, takes that number of zeros and converts it actually into zeros. So if, let's say, this number of zeros is 3, this will return 0, 0, 0. And how it does this, so I use this type of for loop a lot in my code, so I'll explain it once. It creates a temporary variable, in this case I'm calling it A, and assigning it a value of 0. And then while A is less than a specified number, in this case num zeros, in this specific example 3, A will increase by 1. That's what this plus plus means. So in short, this for loop, I hate how these things keep on popping up, sorry. In short, this for loop will repeat this number of times. So for example 3, so the first thing in here is it's creating a string called temp0, short for temporary 0, which is just character 0, and then adding that to this zeros variable. So if this happens 3 times, it'll add 0, add 0, add 0, and the string zeros will store 0, 0, 0. And then I'm creating a new a variable called number2convert, which is that amount of zeros plus that binary number. So this is creating a new string, which will always be 8 digits long. And this is the final version of the binary number. So here I'm taking that number2convert and turning it into an array. So this function toCharArray will convert this string here into an array where every item in the array is a character in the string. And this for loop down here is used to convert this character array into an integer array. And like I said earlier, integer is numbers that you can calculate with, so I'll need that for the shift register. So it's the same type of for loop that I explained earlier, so this will repeat 8 times because that is the number of items in this integer array, because I have 8 bits of binary, 8 LEDs. And I'm not actually 100% sure why this works, but when you subtract character 0 from a character, it will give that, if it's a number, it will give that integer equivalent. So it's really helpful. I learned that from Google. I didn't know that. In this commented out section, I used during the debugging process to print this array here to the serial monitor so I could see if it was making that array correctly. And then here, this section is a little bit unrelated from the rest of this function, but I'm including in this function. You'll see why it makes sense later in the code, but I'm including in this function because it'll mess up the prints the serial monitor if I include it later in the code in the main loop. But this is just printing the number onto the LCD. So I'll explain this later, but first digit, second digit, third digit are the variables I use for the hundreds, tens, and ones place of the LCD. And this is just printing it in a way so it looks like a 3-digit number. And then down here, I'm using that shift right function I explained earlier to actually illuminate the LEDs to the right way. So this here, 7, 6, 5, 4, those are the LEDs. With this being the first one, like the way it's wired, 7 is one all the way to the left, 0 is the one all the way to the right. So I'm writing the one all the way to the left. The first item in the integer output array to the second LED to the left, the second item, and so on and so forth until it successfully prints the binary number. This last part of my code is the main loop, which will run over and over and over again while the code runs. The first thing I'm doing in here is creating 2 variables. One is storing the value of the button, one is storing the value of the potentiometer, so I can just write value button or pot instead of having to write digital read 7 or analog read 4. And here, this loop here controls this button counter variable that I declared earlier and explained earlier. So if value button equals 2, or in other words, if the button is pressed, and then if the value of button counter is less than 2, add 1 to it. So whatever button counter is, add 1. Else, so if this is 2 or greater, but it won't get greater than 2, set it to 0. So basically, when the button is pressed, button counter will increase by 1 until it gets to 2, and then it will max out and get set back to 0. And you see this with when I press the button on my circuit. The little indicator that shows what place you are controlling will move, and that's what these loops are used for. So here, if button count equals 0, so this is the first setting that this could be. I use this for having the potentiometer control the hundreds place. So here I'm printing that little dash you see. This will go under the hundreds place and indicate that you're controlling the hundreds place. And then here, if the value of the potentiometer is less than the potentiometer max divided by 3, so if it's in the first third of rotation of the potentiometer's full range, this is where that pop max variable is helpful. The variable first digit, which I mentioned earlier, is equal to 0. If it's in the second third of the rotation, if it's greater than pop max divided by 3 and less than or equal to 2 times pop max divided by 3, or 2/3 of the rotation, that digit equals 1. And if it's greater than 2/3 of the rotation, it equals 2. And then for if button counter equals 1, I repeat the exact same process, but with 9 digits instead of 3, because, or sorry, 10 digits instead of 3, including 0. Because there are 10 possible digits that the second digit could be, and then exact same thing for the third digit. Then I'm creating a variable called conversion, which is the actual number that these 3 digits are creating. So 100 times first digit plus 10 times second digit plus third digit will give me that number. And then if conversion is less than 255, in other words, if it's a number small enough that can be successfully printed onto the LEDs, I perform that convert to binary function I explained earlier, with the input being this conversion number. However, if it's greater than 255, I do that print too big thing I showed you earlier. And then here, I'm printing the value of the potentiometer to the serial monitor, so I can update the potentiometer maximum value if needed. That's it for my video. Thank you for watching. Hope you enjoyed.